Some bright lining, because India today has stronger strategic intent, more industrial appetite, more serious private sector participation, with a clearer understanding that advanced material are foundational, not ornamental. The future belongs to nations that can combine lightness with strength, heat resistance with durability, innovation with industrial scale. We have the talent, the need, the demand. Now we must build the discipline to convert all that into hard reality. Because in the end, aerospace power is not built by mere announcements and symposiums. It is built by materials that work, factories that deliver, and systems that scale. I welcome all the speakers on the panel. I will request all the speakers to confine your discussion or your presentation to 10 odd minutes so that we give audience enough time to explore actually whether your expertise has got some depth. Thank you very much. Jai Hind. May I now request Dr. RK Rayudu to speak on reducing the import dependency for future aerospace projects.
Respected dignitaries and audience, good morning. My presentation topic is indigenization of aeronautical metallic materials for LCA Tejas for self-reliance and capability building. From the beginning of LCA program, the government approach was not only the aircraft should be built, the materials required for combat aircraft also should be indigenized on par with other technologies. That was the motto. In that motto, we have made a lot of efforts to indigenously develop the metallic materials with Midhani and Ordnance Factory Ambajari. That details we'll be seeing. This is my plan of presentation. Aeronautical metallic materials, design and quality requirements, general requirements, and aluminum alloys, titanium alloys, and a specific component of titanium, then shape memory alloy, ferrule rings, LCA steels, and then achieving self-reliance way forward. When we see aeronautical material, we cannot accept the ground application material in place of aeronautical material, because this issue sometimes comes up with some manufacturer down the line in the supply chain. They make the part with ground transport or general engineering material specification and then come back saying that this is, please accept this material. Like you see, 2014 extruded bars is having ASTM B221 specification and aeronautical grade specification BSL 168. So while procuring the material itself, the manufacturer should adhere to aeronautical specification. And ultrasonic quality is utmost important. Then traceability of the material to original mill who made the actual material, that also is important. Then when the material is made, material melting and refining process is very important, and because that decides the inner quality of the material. And we can see any indigenous material that has to be approved material through CEMILAC and DGAQA through type testing. We can see here a comparison between general engineering material and then aeronautical quality material. The first one, BS5S99, he is BS5S99, indigenous grade is MDN99A, that is Midhani grade. Whereas ASTM A29 is general engineering. You can see a sulfur content in the one. First one, both are the same grade, ASI 4340, but the first one is having 0.015 sulfur, whereas second one is having 0.040 sulfur. So higher sulfur content, it makes material dirty at microstructural level, and it gives poor properties, fatigue properties. The life of the component will fail prematurely in the service. So it is very important to stick to aeronautical grade specifications. And this slide shows aluminum alloys used in LCA Tejas. And aluminum alloys are, thanks to Ordnance Factory Ambajari, presently Yantra India Limited, Nagpur, they have indigenously developed on our request indigenously developed extruded bars of 2014 and 6082. And forging feedstock also has been indigenously developed with OFHI. We are self-sufficient in terms of extruded bars and then forgings. Extruded bars also up to 32,500 square mm, it was indigenized, and beyond that, because of infrastructure limitations, it could not be done. Now, Ordnance Factory Ambujari, they are upgrading the infrastructure facilities. So in future, we'll be getting the 100% extruded bar self-sufficiency, whereas plates and clad sheets we are still importing. You can see 40% is the aluminum content in LCA, structural weight. And these are some of the typical parts of aluminum parts in LCA. So long, like extruded parts, longerons, bottom longerons, and extruded fuselage stringers, they are made from extruded bars. And forgings, dry-pay bracket, fin root fitting, these are made from forgings. If you see the frame, right side corner, 5-1 we have highlighted with, that is the aluminum temper, that is control structure temper it is. If the 5-1 is not there, the part will warpage during machining, and it will not have sufficient dimensional stability, and poor fatigue properties will result. So material has to be produced in that temper condition and procured in that temper condition. That is a limitation in the present in the country. We do not have the structure presses of that capacity. That is why we are importing. And this is the present status of aluminum alloys. We have plenty of bauxite reserves, 4,958 million tons. But if you see the plates, aeronautical quality plates, we are still importing. And sheets also we are importing. So for this, we have approached some private companies like Hindalco, but the investment is, capital investment is required for making this downstream facilities. So we could not progress that in that front. And coming to titanium, we have around 1.5 tons requirement per aircraft is there. And here we can see some of the parts, titanium parts. Titanium is, see, that is double the strength compared to aluminum, but the cost-wise it is 2 to 3 times costlier than aluminum. But still people go for titanium because of these advantages. If you see the, this special bolt, that is made of titanium 31A, that is titanium 6 aluminum 4 vanadium, that is methane material. But if you made from steel, that weighs around 2.4 kg. But if it is titanium, it is 1.4 kg. 1 kg we are saving per bolt, and the 4 such bolts are, 8 such bolts are required. This is 47 diameter bolt, and 47 diameter 4, and then 40 diameter 4. 8 such bolts are required to fix the wings of the LCA to the main body. So 8 kg we are saving by going to titanium. But I will share one more slide in future. That one, the challenges what are involved in the titanium special bolt manufacturing. And these are the other parts. And the extreme right side is the titanium turkey feather components, which are made from OT4 4-1 sheets, which are made at Mithani. And this is a titanium raw material and indigenous capacity information is given here. We have abundant ilmenite and rutile resources. As morning Kamal Saab was mentioning, we have plenty of raw material resources are there. Capacity, production capacities are there. But here the challenge is, as morning Kamal Sir was mentioning, KMML Kerala, they have sponge iron plant. Sponge iron and then master alloys are the one of the critical ingredients for the titanium manufacturing. So there is some technical issues are there with them. They are upgrading, but to make it more economical, we understand they are planning for technology upgradation, and they're going for 1,000 TPA. Then PTC Industries Lucknow, they're also coming up with a bigger facility. So production point of view, production capacity point of view, there is no limitations with titanium. Only limitation is if you come titanium thin sheet rolling. Thin sheet rolling, where we are not having the very good quality sheets from Mithani, especially below 1 mm thickness, we are having waviness and the sheets are not good quality. So the cold roll mill upgradation is required there. And this is one special titanium bolt technology what we have indigenously developed. That is what we have shown, that 8 bolts, such bolts are used for LCA wing attachment. And here, earlier it was imported from single source. We have developed all these technologies with HAL foundry and forge and private industry. Now all LCA requirements are met through indigenous sources like HAL foundry and forge and Amador Tools, Bangalore. And this is one more important indigenous development. In 1998, when Operation Shakti, the Pokhran 2 tests were done, so these shape memory alloy ferrule rings were under sanction. So we were faced with sanction, thanks to sanction by abroad sources. But that we took as a challenge, and then we have indigenously developed with BRC Mumbai, and then production technology has been transferred to HL Foundry and Forge. Now around 250 such ferrule rings are are required for LCA, and then all the aircraft we are making indigenously with the foundry and forge. And peak insulators, they were developed with DMSRD, DRDO lab, and those are also now later on the transfer of technology happened to Mars Auto. So now both these critical parts, they are presently indigenously met. So these are some of the steels. All LCA steels, we can proudly say, the Mithani and DMRL, they have supported us, and they have made the technologies available indigenously. So all the steels are indigenously sourced with Mithani, and later on some private companies also came up, like Sunflag, Nagpur. So we can say steels are 100%, we are self-reliant. And these are some of the maraging steel parts and the landing gear parts, and there are the actuator parts, and then the maraging steel wing spigot. And so in nutshell, we can say self-reliance, way forward. Aluminum alloys, we have to go longer way for plates and clad sheets, whereas titanium alloys, thinner gauge sheets, we have to invest a little more and then get good quality sheets. The steels and nickel alloys were self-sufficient. So self-reliance through strategic autonomy, that is strategic investment versus investment on returns. So we have to see whether it is to be independent on strategic sector, the investment on plate rolling and plate stretcher press and clad sheet facilities, they all have to be set up in the country. Thank you.